Hi, I'm Zheng Chenxun. This is our data mining final report, and this is our team members. The first part is metadata. This data is open data from Taiwan government and is talking about the traffic accident in Taichung City. Our purpose variable is 事故种类. It means the type of accident. For example, one for someone died in 24 hours. You can see it doesn't mean 1 is 1, 2 is 2. So we regarded this kind of data as categorical. And when we process it, we will turn them to string. Except the purpose variable, we have 16 independent variables and more than 6,000 records. The next page is still our independent variables. We can just give it to data processing. In the first picture, it shows we have more than 22,000 missing values, and we will find most of our missing values is one type of accident. So we use type 3 mode to fill in, and we don't describe because our continuous variable is count of people. It already have described concept. Encoding, we choose one-hot encoding because they don't have order relationships. When we do one-hot encoding, we have filled the original meaning in case they have same color name, just like the second picture show. And we use 80% for trending, 20% for test. Next part is select attributes. Using a variable for trending accuracies is 99.27%. For chi-square, we say k equal to 5, but we find it have same accuracies to all variables. For Occam's razors, we can now choose this variable when they have same accuracies. So we make a for loop to find when the accuracies change. And finally, the result will send us select from tree. It will choose 2. So they have same variables and accuracies and importances.
Hi, I'm Bert Wang. This section is the decision tree. The attached figure shows the model accuracy of the C4.5 algorithm. In the case of n equals 2 to 4, the model accuracy is the highest and equal. Considering the value of n and the simplicity of the model, we choose the model with n equals 4 to represent the results of C4.5. The figure shows the results of the Kac algorithm model accuracy for n equals 2 to 10. The model achieved the highest accuracy at n equals 2, so we select it as the representative of the Kac algorithm. In the case of using all variables, the Kac algorithm achieves a training accuracy of 99.27% and a testing accuracy of 99.05%, while the C4.5 algorithm achieves a 99.32% accuracy. On the other hand, in the case of selected variable, the Kac algorithm achieves a training accuracy of 99.27% and a testing accuracy of 99.10%, while the C4.5 algorithm achieves an accuracy of 98.91%. C4.5 has the highest model accuracy when considering all variables. We will focus on this model as the primary model for further discussion. We'll introduce estimating generalization errors. Given the non-accuracy and the number of tree leaves, we can calculate the error rates under optimistic approach, which is 0.684%, and the error rates under the pessimistic approach, which is 3.684%. When there are injured individuals in a traffic accident case and they have not died, the event is usually classified as a type A2 incident. If there is no record of injured individuals in the case, it may be because the person involved in the accident died at the scene. And such cases are classified as type A1 incidents. If the severity of the injuries is categorized as the third type, no injuries, or if the injury status is unknown, this is typically classified as a type A3 incident, which involves only property damage. There is also a small portion of cases in which the individuals involved did not sustain any injuries, and these are classified as type A3, A4 incidents, which are resolved through self-settlement.
I'm Lin Tingyu. I'm going to introduce association rules. First, using Python, we found that regardless of setting a minimum support as 0.07 or 0.03 and the minimum threshold as 1, we couldn't find any rules where the accident type equals the vehicle itself or level cross accidents. Next, we use the R program with two criteria, support and competence. Still, we couldn't find any rules where the accident type equals the vehicle itself or level cross accidents. To solve this problem, we resample the data. After resampling the data in Python, we obtained around 60,000 rules. We selected 2 rules with the highest supported competence. According to the index 28, having lighting causes good visibility. According to the index 648, having lighting and not defects on the road surface cause good visibility. After resampling the data in R, we obtained around 17 rules. We selected 2 rules with the highest support and competence. According to the index 32, having valid driver license and not drinking alcohol cause accidents of the vehicle itself. According to the index 33, on a sunny day, having a valid driver license cause accidents of the vehicle itself.
Hi, I'm Yilu Chen. I will introduce 2 parts, SVM and random forest. First of all, I use 2 ways to optimize model performance. The first is manually queuing hyperparameters by giving different values to the parameters. And the second one is applying randomized search CV. Then according to the article, we can find the recommended settings, which are setting C at gamma between 0.1 to 1. Therefore, for the full test data, we make C unchanged, which is 0.1, but gamma will increase by 0.1 in every test to look for the best accuracy. Firstly, gamma is equal to 0.1, and then increase gamma to 0.2, the accuracy goes up by 4%. In the same way, gamma increased to 0.3, but the accuracy decreased 1%. Similarly, the accuracy also descending 1%. And on the other hand, I decide to apply a more efficient way, grid search CV. It doesn't need to tune parameters manually, but maybe the process is too complicated, so it doesn't run successfully. However, based on another article said that another way, randomized search CV, is better when conducted, and the outcome is better. So next, based on the recommendation setting above mentioned, I define the parameter range for gamma and C. Starting from 0.1, increase both values by 0.2 in each iteration, and use randomized search CV to randomly select and find the best parameter combination from this range. And after training, obtain the best parameter setting C is 0.9, gamma is 0.3, as we see from the blue frame at the bottom. And take the best setting into SVM. It gives the highest accuracy, 0.97. And next, random forest. Also, according to the article, it recommends that we can set an estimators between 1 to 200 and set mass depth between 10 to 100. So for the full test, we set an estimator equal to 150, remain unchanged, and mass depth increase 5 in every test. And in the beginning, mass depth begins from 5 and increase. We can find when mass depth becomes higher. The accuracy performs better, proof the article said. Then, in random forest, we also use random my search CV. I set up a parameters range based on the article, and similarly, it gives us the best parameter setting in this range. And take the best setting into random forest, gives the highest accuracy, 0.98, and so surface. We also optimize our model.
I'm Zhang Ziyu. I will talk about KNN. To pick the best value for k, I use the for loop to integrate k from 1 to 1365. The result shows that the highest accuracy occurs at k equal to, and the accuracy is about 94%.
I'm Lin Tingyu. I'm going to introduce comparison of training accuracy among different methods. As we can see, the random forest model achieved the highest training accuracy of 0.9875. The training accuracy of hard voting and soft voting is similar. Therefore, the best model is random forest.
And Zhang Ziyu 10 hierarchical clustering and k-means. This diagram shows that we should divide this data into 3 clusters because it has the widest branches. From the screen plot, curve falls suddenly when k is full, and there is no significant change afterward, so we think that dividing into 4 clusters is a good choice. We divided the data into 3 and 4 clusters. According to the result, when the number of clusters is full, the sum of squares error is smaller. Therefore, setting 4 clusters is our final decision. Now, let's take a look at the characteristics of each cluster. 1. A district driver of a sedan passing through Xichun during the day. That person will have a type 3 accident. 2. A scooter driver not paying attention to the road situation while going through Xichun during the day. That person will have a type 2 accident. 3. A sedan driver driving at night in either Nantong or Shalu fails to maintain attention towards the road ahead. That person will have a type 1 accident. 4. A sedan driver failing to yield to an advancing car while driving in Xichun during the day. That person will have a type 2 accident. This is the prediction accuracy of the data divided into 4 clusters. That is almost 98%.
I'm Lin Tingyu. I'm going to talk about best predictive analysis model. As we can see, the random forest model achieved the highest testing accuracy of 0.9875. The SVM model has the lowest accuracy. Therefore, the best predictive analysis model is random forest, while the worst predictive analysis model is SVM.
Hi, I'm Chen Yuwen. In the final session, which is the conclusion, based on chi-square test and decision tree model, we have identified the 2 most important variables, namely 死 and 受伤, with an accuracy of 99.27%. Additionally, through the analysis mentioned above, we obtained several results. Firstly, the random forest model performed the best in this analysis. Secondly, based on the results of hierarchical clustering and k-means, we decide to divide the data into 4 clusters. Lastly, through association rules, we discover certain causal relationships. For example, accidents involving appropriate driver's license and non-alcohol consumption were classified under the category of the vehicle itself. The following is our work assignment table. With that, we conclude our report. Thank you all for listening.